We're going to create a quadratic model. This time we're going to be using Vertex Form. Now this is our Vertex Form. You guys remember it from before? We still have an A value. The A value is identical to our A value in factored form. Our H and our K refer to the vertex. Okay? And the vertex, our X value and our Y value of our vertex, are our H and our K. Okay? And again, usually it is the opposite of what the operation is for our H. So, what we're going to do is we're going to try to get a quadratic model or a parabola that kind of models what this part of the Eiffel Tower looks like. It looks very similar to a parabola. It may not be identical, but we're going to use some estimation here. Now, the reason I'm using vertex form, we did factored form before. Does this parabola itself cross our x-axis? No. So, will I be able to use my factored form to solve this? No, I won't be able to get it. There is no x-intercept of this parabola. It's below the x-axis. So I have to use a different form of the model to actually create this with. So we're going to be looking for the vertex. So I'm estimating that the vertex is roughly right about there. Okay? And if we're counting across, that is a value of 1, 2, and it goes down from the x-axis 1, 2. All right? Yeah. So it looks like our value is at 2 and 2, our vertex here. So we're going to use that. This is our x value and our y value. Sorry, you're right. It is -6. Thank you. So in our form, f at x is equal to our a, x minus h squared plus k. Since our vertex is the value of 2 and -2, and this is our x and our y of the vertex, we're going to be plugging these values in. Give me 1 sec. Okay, so we have our vertex form. This is our x value, a positive, and our y value is negative. So our y value represents our k. So we're going to plug k with -2. We're going to plug -2 in for k. And in for h, we're going to plug in +2. And this is very similar to the effect that our vertex form has. A is equal to x, subtract, and in this case, it's +2 we plug in. Okay? And then our k value is -2. So again, because the formula has a negative here, it turns our positive value into what looks like a negative. Hence why our h movements, when we translate them, we always think of them as being opposite. A times x minus 2, and we know that means it's +2, the x value. Subtract 2 again. What is the only variable we're again missing? A. We need to solve for A. So, using the knowledge that we use for factor form, what should we do here?
Find another point.
Find another point. So let's say we're traveling across here. This looks like a relatively round number. Again, we could use any of the values in here, assuming this is a parabola. We cannot use the vertex again.
No, like just go below vertex.
Is this where our parabola is, though? It has to be actually on the path of the parabola we're trying to find. Okay, so we have to find a coordinate on there. So I'm going to choose that value because it looks like it's probably 2 whole numbers. Again, this time we're at -2 and -4, I think. -2 and -4. Okay. So with that information, we're going to plug that in for our y and our x in this case. Our y value was our -4 is equal to a, and our x value was -2. -2, I'll write that one in red. Okay. Squared -2. Sure, I have a lot of -2s here. So again, the whole goal is just to isolate a so we can find out an a value. We have -4 is equal to a. -2 minus 2 gives us -4 squared minus 2. -4 squared is going to be what?
16.
Yeah, so we'll have 16 times a minus 2. We bring 2 to the other side, what does it become? +2. 16a. We're going to get a -2 is equal to 16a. And when we bring 16 over, we'll get -2 is equal to, -2 divide 16, or -1/8 as our a value. So for our factored form, we use this form and just plug that in for the a. f at x is equal to negative 1/8 times x minus 2 squared minus 2. Okay? So there's our work for determining the model of the